Hello and welcome back to the lecture of time series econometrics. We have been discussing the concept of forecasting in time series econometrics, and in this lecture we are going to actually do hands-on for a particular command ETS in R, okay? And we have explained the importance of ETS. It is something that actually helps us to identify the nature of the trend, seasonality, and the error term, if that is additive, if it is multiplicative, or if they are not there. It is sort of helps us to fit the model, but it doesn't really forecast the model. So we have to run different commands for forecasting. We're just going to see that. We can play with the alpha, beta, gamma smoothing coefficients that we have seen in whole to integers exponential smoothing method. So we have lots of flexibility in terms of what model we want to choose. The beauty of ETS is that it actually it chooses on its own from among all these different possibilities, like of the seasonality trend and error term, the best model that we can possibly get. And we can identify the best model for us either graphically. We can visually can understand that which model is fit to the best fit, or even better is basically to look at the model fit. Basically, we see the AIC value, Akaike information criteria, the corresponding value for that, and yeah, so basically error term. So there are different ways of minimizing error term, which we are going to see. We also plot some residuals, and we can see how that will actually help us to understand uh, uh, the best model. So so let's just start without further ado. So first, to run ETS, we need to have the forecast package installed. So that's the first thing, and then I will update the forecast package in my library. Now I am going to use this TSPPI dataset. TSPPI is that purchasing power index for US economy, and the TS is a time series form of it. So we have defined TSPPI here, so we don't need to define it again. So it's a quarterly data set, and starting 1960 ending in 2002, and we're just going to plot it. And the basic of ETS command is a very basic structure. So what I'm going to do here is I'm going to I've lost it somewhere. Where is it? Okay, here is my ETS command, right? So I'll just define the alpha here. Okay, even if I don't define alpha, it will pick up alpha, beta, gamma, all those different values. But let me just pick alpha here, and let the model decide the corresponding other smoothing coefficients. Okay, so the model has run well, and then I print the results. Okay, and I see the results here. So here I see that I get the different estimates of error, RMSE, MAPE, MAC, on all this error. We can look at the AIC. AIC is 912. But more importantly, what we need to see to actually, when I actually look at the model, is that what are the smoothing parameters I've got? Alpha equal to 0.2 I have defined. So model itself has chosen beta equal to 0.2, gamma equal to 0.5, and phi is a damping coefficient. We didn't discuss that. We discussed that ETS actually chooses the initial value, initial state. So L is equal to 25. It has chosen. Beta is a slope that we go get from the trend. It is 0.0076, and S is the seasonality index. So we get all these values for the 4 different seasonality. Okay. So that's basically it. And what we can do is, so what ETS has done is, okay, so now we come to the diagram, and you see here ETS in bracket MADA. So which means that you have a multiplicative error structure, there is a additive trend, and there is a additive seasonality. Okay, so that would mean that your model has both trend and seasonality, which is important for us to know, and it will sort of yeah, so it will sort of like provide this kind of details. So now you can actually change it if you want. You can decide that I don't want say seasonality at all, or I don't want my error term to be multiplicative. It has to be additive only. So you, all these things you can force into this model, and that's one beauty of it. So we'll look into it. But before that, another thing that is important for the estimation of the model is to use the residuals. Okay, so if we use this command check residuals, which is a very important command, a very simple but yet really powerful command in R. Is you can actually put the model there, and what this command will do is it will actually pick up the residuals and plot them. Okay, it will also plot the ACF for the residuals. It will automatically do the Leong box test, and so that way we will identify if there are significant autocorrelation structure in the error term. If there are significant autocorrelation structure in the error term, then you will say that there are some problem, okay, because my model couldn't capture all the patterns in the data, so it is being captured in the error term. So here we see the ACF, it looks like ACF is significant, and we'll see in Leung box test result here is that it is saying that p value is pretty low, so which means that my null hypothesis is of no autocorrelation is not true. So which means that there are autocorrelation. So we need to be a little concerned about the model. It also plots the error term and it shows some somewhat normality, but then there are some like observations which are beyond like quite it looks like a high variance observations. There are some of the observations are quite yeah, beyond the normal curve. So then we need to be a little concerned that okay, some errors we need to actually take into account. Now, okay, so now I said that we will be, you know, fitting, you will be actually, um, you can actually force different criteria on this model, okay, and that's exactly what I'm going to do. So here I'm going to write alpha equal to zero point 0.2, beta equal to null, gamma equal to null, and there's another parameter lambda. I didn't explain that. So lambda is basically, if lambda is equal to true, so what my command will do, ETS command will do is it will transform the model suitably. Suppose if it's a linear model, but and it's not fitting really well, so it will take the liberty to transform it into a say log model or some other form of model, log linear. So it will check all these different model forms to see which one fits better. Okay, but I have defined lambda is equal to false. I don't want my data to be changed. It should be as it is. Then I have written additive only. So I want all these different parameters to be additive, like it cannot be multiplicative. If I write it false, then it will it will take the liberty of actually yeah introducing multiplicative also. Or if I want to allow multiplicative trend separately, so it will allow multiplicative trend. If I write it true, it will allow multiplicative trend. If I write it false, it will not. So that's basically that's the different ways of defining the parameters. And if I run it, it has run well, and if I plot it, I will see how it looks like. So we got some slope, and okay, let me actually get the result. That would be important. I need this command. I need to write print, right? Print, and if I write it, I will see. Okay, I'll see the AIC value. AIC value is 0.434. Okay, so initial level and all these things have reduced quite significantly actually. Okay, let's see that. So now I have got no seasonality, only additive error and additive trend. So that's what I got. Okay. So that's how I have actually changed my model, right? I forced my model to change, and here I got some AIC value which is 434, and my previous AIC value was probably much higher. Let's see how much was it. 912, right? So probably I'll go for the second model where I'm fitting all these different criteria. Okay, so that's how we need to check the different parameters and see which one is actually going to work. Suppose here if I write true and if I run it again, and if I actually see, it didn't change much. Let's see the form of the model. It is oh, it's still additive. Okay. Oh, I've written additive only is true, right? So that it will be additive. Okay. So yeah, so it didn't change much. So I mean, this is how we can actually play with all these different parameters, and this is basically the fun part. And you should do it when you are actually working with this data set. Okay, so far, so that's about the that's all about the hands-on with the ETS command.